There are discoveries that adjust a theory, discoveries that refine a model, and then there are discoveries that tear the entire scientific foundation apart. What has just appeared in astronomical data belongs to the last category. A new object, apparently a planet, has been detected orbiting a distant star, and everything about it suggests it should not exist. Not unlikely, not rare, not unusual, it should not exist in this universe, under these physical laws, in this cosmic era. Yet, according to every repeated measurement, every recalculated orbit, and every attempt to invalidate the results, the object is undeniably real. The first signs appeared quietly, almost accidentally, during a deep observational scan of distant star fields. These scans are routine, a constant background hum in the world of astronomy. But something was wrong. Instead of the smooth, predictable dips in starlight that indicate a normal planet passing by, the star began flickering in a way that defied sense. The drops in brightness were too fast. Far too fast, so fast that the detection algorithm flagged the data as faulty. Yet when technicians repeated the scan, the same anomaly resurfaced with shocking consistency. The star's light was dimming and brightening at intervals far too short for any natural planet to be responsible. At first, researchers suspected a malfunction, but the instruments were flawless. Every redundant system reported the same absurd conclusion. Something was orbiting that star at a speed that breaks the known limits of physics. The orbital period was measured not in days or weeks, but in a handful of hours. Hours, a speed so extreme that any planet should have been torn apart by gravitational shear, roasted by heat, or pulverized by tidal forces. And yet, impossibly, the planet remains fully intact. This revelation immediately ignited a shockwave through the scientific community. Researchers in astrophysics, orbital mechanics, thermodynamics, and particle physics all converged on the data in disbelief. A planet orbiting this close to a star is already an extraordinary event, even under normal conditions. But a planet orbiting in mere hours? That belongs to no known category. Even ultra-hot super-Earths, the most extreme objects in planetary catalogs, do not behave like this. They do not orbit this fast. They do not sit this close. They do not survive these temperatures. To understand the scale of this anomaly, consider Mercury, the fastest planet in our solar system. It orbits the Sun in 88 days. This object completes that journey in a timescale thousands of times shorter. And unlike Mercury, which remains at a survivable distance from solar annihilation, this newly detected world orbits so close to its star that the heat alone should destroy it instantly. Astronomers estimate its surface temperature exceeds 3,000 degrees Celsius, hotter than molten steel, hotter than lava, hotter than the surface of some smaller stars. No atmosphere should survive, no rock should remain solid, no core should endure the pressure. Yet this world endures all of it. The mystery deepens further when examining its density. The planet is far denser than any known world of comparable size. Its mass suggests a structure so compressed that it borders the domain of stellar remnants, objects left behind when stars die violently. Normal planets cannot physically reach these densities. The universe's natural processes do not allow for it. And yet, here it is, a world packed with material so heavy, so resistant to destruction, that it challenges every model of planetary formation ever proposed. This has led scientists to propose a possibility that once would have been dismissed as science fiction. The object might be the exposed core of a once massive star. A stellar corpse, a fragment that somehow survived destruction and found itself orbiting a younger star. But even this explanation collapses under scrutiny. Such a core should not remain stable under these orbital conditions. It should collapse, fragment, or spiral inward. But this object remains perfectly balanced, as if locked into its orbit with impossible precision. The deeper the analysis goes, the worse the contradictions become. If the planet did not form near the star, which it absolutely could not have, then it must have migrated inward. But such inward migration is catastrophic for any world. A planet dragged toward a star faces unimaginable violence, tidal shredding, gravitational turbulence, atmospheric stripping, thermal annihilation. No object should survive such a journey intact. And yet, this world displays no signs of trauma. It is complete, whole, geometrically sound. It carries none of the fractures or atmospheric scars normally associated with planetary migration. Another theory was considered. Perhaps it was captured from outside the system. A rogue world drifting through space until a star's gravity snared it. But a captured orbit is never circular. It is messy, elliptical, unstable. By contrast, this planet's orbit is nearly perfect, a clean, smooth circle, the kind that forms only through natural, uninterrupted development. That leaves the scientific community with a terrifying possibility. Either the theories are wrong, or the universe is hiding rules we have never encountered. This object's survival in the face of extreme radiation defies thermodynamics. Its ability to maintain a stable orbit defies gravitational modeling. Its density defies formation theory. Its internal structure defies geology. Everything about it is wrong. Everything about it is impossible. Yet it exists. As these findings spread across institutions, new teams joined the research. Particle physicists suggested exotic matter might be responsible. Exotic matter, highly compressed, non-standard atomic configurations, can theoretically survive conditions that destroy normal material. But exotic matter has never been found inside a planet. It exists only in theory and in the cores of dead stars. For a planet-sized body to contain exotic matter would require cosmic events unlike anything in the known universe. A few bolder researchers suggested that this world may not obey the same laws of physics as our solar system. In extreme environments, quantum behaviors can emerge that alter the rules. Under extraordinary heat and pressure, matter can behave in unfamiliar ways. Perhaps, they argue, this planet is a window into those forgotten or unknown behaviors. But this explanation implies something far more unsettling: that the universe is not governed by one uniform set of laws. Instead, it may be fractured into regions, zones where the rules shift, where matter acts differently, where physics bends. This interpretation carries massive consequences. If the universe contains pockets where the laws change, then our entire understanding of cosmic formation is incomplete. Worse, our instruments would fail to detect these anomalies correctly, filtering them out as errors. This planet might only be the first we've recognized, not because it is unique, but because it is the first one too extreme to ignore. As astronomers study the object more closely, one detail stands out: the planet rotates. Normally, a world orbiting this close to a star becomes tidally locked, with one side eternally facing the star. But this one shows signs of rotation, meaning its internal structure must be far stronger than any material science recognizes. To rotate while facing such intense gravitational pressure requires rigidity on a scale no known material possesses. This fact has inspired a new, and deeply unsettling, line of thought. What if this world predates the star it orbits? If it formed billions of years earlier, under different cosmic conditions, then it may be a relic of a universe that no longer exists. A fossil of a physics that operated differently. But this raises another chilling question: how many such relics exist? What if the universe preserves objects from epochs governed by laws we no longer observe? What if this planet is not the first anomaly, only the first one we've detected? One high-level researcher summarized the situation in the most unsettling way possible: this planet is not an exception to the rules. It is evidence that our rules are incomplete. The problem grows even larger when analyzing the planet's star. The star behaves normally, no anomalies, no strange emissions, no unusual gravity. Yet orbiting this ordinary star is an object that should not be able to exist even near an unstable star, much less a stable one. This pairing makes no sense. The star is conventional, but the planet is a cosmic rebel, an outlaw object refusing to obey any known laws. Theories now range from radical to unprecedented. Some suggest the planet was forged through a catastrophic cosmic event unlike anything recorded. Others propose that it passed through an exotic region of spacetime, a gravitational knot, a quantum turbulence zone, a relic boundary left over from cosmic inflation. These regions could theoretically compress matter, distort orbits, or stabilize impossible structures. But again, these are only theories, lacking any observational confirmation. Yet the planet exists. That alone is confirmation that something extraordinary has happened. Scientists examining its longevity estimate that the planet may have survived in this orbit for far longer than any human model would allow. This suggests a degree of internal stability that defies logic. A normal planet would have evaporated, exploded, or disintegrated within minutes or hours. But this object persists across cosmic timescales, which leads to perhaps the most alarming question of all. What if the planet possesses a mechanism, an internal process, that allows it to resist destruction? This theory terrifies researchers because it implies intention. Not necessarily life, not consciousness, but a physical mechanism that acts with purpose. Something like self-regulation, self-cooling, self-stabilizing under unimaginable stress. Mechanisms like these have never been seen in nature. They would require physics far beyond what humans have discovered. If the planet is self-regulating, then it is not merely a relic, it is an engineered object. A creation, a manufactured survivor of cosmic catastrophe. But engineered by what? By whom? Under what conditions? And for what purpose? Most scientists avoid this line of thought entirely. It is too speculative, too confrontational, but the data does not care what scientists are comfortable with. It continues to show an object that behaves less like a planet and more like a designed survivor. Yet even without resorting to theories of design, the planet's existence alone is a wake-up call. It means the universe contains marvels we are not equipped to understand. It means our models, our equations, and our assumptions may be simplifications of a far deeper reality. And as this impossible world continues to orbit its star, unbroken, unburned, undevastated, the scientific community is left with a lingering sense of cosmic humility. If this planet can exist, then the universe is not just stranger than we imagine, it is stranger than we can imagine. The discovery of this impossible planet is not the end of a mystery. It is the beginning of a new understanding, a realization that the cosmos is not a perfect machine obeying neat equations, but a wild, ancient, unpredictable expanse where the impossible is sometimes simply out there, waiting to be found.